Right. You see, the networking is the most wanted, at the same time, easy to understand subject. See, everywhere there is network. There is no place today without network. Even if you go village, you can see people using WhatsApp, people transferring money through cell phones, buying through Google Pay. This is one field which will keep growing, and also it is a very easiest subject to understand. It's really easy to understand. When we have that interest of learning, that that is more than enough. You don't need to have too much of mathematical or physics or chemistry knowledge to understand this. Anyone can start at any point of time and they can master the subject and they can shine out. Yeah, you can easily shine out than any other software guys or any other department guys. This is such a nice program, learning networking, and you are into CCNA. Cisco is one of the vendor, very popular vendor in designing network related devices. Cisco is a company who have designed many devices that supports internet work. Devices like switches, routers, firewall, SAN device, storage area network device, even some servers, and also many application oriented tools to manage these devices. So they are very popular. Cisco is very popular, more than any other vendor on earth. Now, Cisco not only designs these devices, they have also designed curriculum for people to easily learn and master networking step by step. Now, the very first certification in Cisco, the certification which covers all fundamentals, the most important fundamentals, CCNA, Cisco Certified Network Associate. This is what you are learning now, Cisco Certified Network Associate. Now, this one is the most important training because it is fundamental of networking. Only those people who masters this will easily understand the next level called Cisco Certified Network Professional, CCNP. And then next comes CCIE, Cisco Certified Internet Expert. So this is the most important place. Only when someone have this fundamental strong, this foundation strong, they can have these programs well understood and they can become a real true expert. Yeah. So it is important to understand every piece of this program. This is going to determine your career in networking. So if you learn Cisco well, it is very easy to understand the other vendors. So we are not only having Cisco, we also have other vendors like Juniper, Huawei, Zati, and we have Palo Alto, we have Fortinet, and much more. There are many vendors in networking, but Cisco is the pioneer. Cisco is the one which have got a clear uh, open source materials to study. Those who have mastered Cisco, they can they can easily master the other vendors. They can easily work with other vendors. All right. So let's begin our CCNA. So it stands for Cisco Certified Network Associate. Internetworking. What does that mean? Internetworking. First of all, we need to understand what is network. See, when we say networking, immediately what comes to our mind is we have some computers. We got some group of computers that are connected together so that they all can communicate. That's what comes in our mind. But it's not that simple. Networking is not just, computers connecting. No, there are various devices involved in networking. We are not just, having uh, laptops and all laptop stock. No. There is a very big network in the middle. You can call it as the internet cloud, which makes this communication happen. See, this is end user. It's you, me, they. They're all, we are all communicating. We are end users. We are all just end host. You can call it as end host. We are just end host. Only these end host is not networking. To connect end hosts all around the world, there are a lot of other devices contributes for this communication. We simply draw like this, internet, cloud like this. But inside this, there are a lot of varieties of devices. Some are called as switches, some are called as routers, some are called as firewalls, some are called as VPN concentrators, and different type of cables. Some are fiber cable, some are Ethernet cable, some are serial cable. They all put together, we have internet world. So we are not just having one cloud like this, we have many. Let's say this cloud is called as Airtel. Like Airtel, there are many internet service providers. There's a service provider. There are many service providers around the globe. In every country, there are many, many service providers. Tata, you know, Geo, Etisalat, Telecom Italia, French X, VTI. We have various service providers around the globe. Orido, there's a ISP called Orido, which is popular in Doha, in Qatar. So we have various service providers, all connected together. They form one internet. So internet is not just some group of connect computers communicating. It is the entire world connecting together to communicate. See, we not only communicate, we also share resource. For example, you are using Gmail. It is because Google have shared their hard disk of 15 GB size to you. That is why you are having Gmail account and you are able to send a mail. I can receive mail. When I send a mail, it comes to the Gmail hard disk, which is given to you. When I send a mail, you see a mail there sent by me. You see the documents that I sent by me, but where are they saved? They are saved in a disk. And who is the owner of the disk? Google. They have given you 15 GB for each person who opens a free Gmail account. 15 GB is given to them. So what do you understand? A resource have been shared with us. A hardware has been, a hard disk, a storage has been shared with us. So internet is not just connecting computers to communicate. It is also connecting various resources like hard disk, processors, RAM, and much more. People share libraries, online libraries. We just pay some money and we read books, thousands of books, online library. That's the resource that they are sharing with us. You know, we have a lot of online schools, music schools. You pay money and then you start learning music automatically. Whenever you want, you can learn it. There is no master, there is no people teaching there. It's pre-configured lessons, pre-designed lessons to learn music. So internet is a group of devices that is to communicate, that is to share resource such as hard disk, printers, even printers. It is shared. If you have seen in any MNCs, if you go to big companies, you will have one big printer for the entire office. Everyone will give print from their laptop, from their computers, and they go and collect their printouts from one common printer. How is that possible? One printer for 1,000 employees? You can share printers in the network. That is how it is possible. So, internet work is not just computers connecting, various devices, scanners, printers, hard disk, processor. You know, hard disk, we understood Google is giving hard disk. A library is being shared, which means their hard disk has been shared so that you can go and fetch some books from the library, read from the library. Now, is that the internet? No, not that. Not only this much. It is much more bigger. Today, internet world is also talking to people like another person talking. Artificial intelligence. That's an internet. No internet, no artificial intelligence. You know, uh, People go to YouTube and they talk to YouTube. You talk to YouTube and YouTube gets the video for you. So internet work is not just devices talking. devices talking to human and human talking to devices. Internet is very big. It connects the whole world. Initially, only computers were talking. Later, Google came. They started sharing their database, and then Google Chrome came, Safari, many more came. And now internet has grown very big, where you can talk. They listen and they answer. You know, they answer your question. They understand your language. So internet is something growing every day. This department will never sleep. Internet is networking is the industry which is keep on growing day by day. A lot of new things. Today we are talking about AI, but there will be much more coming in near soon future. Every day something new comes into networking. So this is the one department which is always growing. Yeah. Now in the internet, if you see, there are a lot of types, models. Some internet services, they provide resource. Say, for example, when we say cloud computing, what does that mean? Cloud computing. You have a small laptop. Let's say you have a small laptop, which is not that powerful, but you want a big server to do some research. You have just a small laptop, but you can still have a server. How is that possible? You subscribe. You subscribe to a vendor like Verizon, Azure. There are many vendors, cloud service vendor. You subscribe, they will slice one big server for you, and they will give you for rent. So you can remotely log into their server and use their server to do your project. Yeah. So that is one type of service. Now, this internet is everywhere. It is not only in cloud, it is there in hospitals. The people diagnose the problem online. Doctors no need to fly from one country to another. Experts no need to fly from one place to another. Remotely, they can they can diagnose and prescribe medicines. People not just talk; they even see them each other and they talk nowadays. We do WhatsApp call, right? We have various even this call. I can see you, and when I have camera, you can see me. So these are all what internet work, right? Now this internet work is possible because of a common standard called OSI, Open System Interconnect. If I speak in Chinese language, will you be able to understand? Because you are not from China, you won't understand. But you see, my laptop is made in China because it's Dell, and who sold this laptop? America. So, made in one country, sold in another country, purchased in India. In India also there is a manufacturing company called HCL. They also have a laptop. They also assemble laptop, assembled in India, assembled in China. But when you connect a wire and communicate, they talk each other. How is that possible? When a Chinese talk to us, we don't understand. But a Chinese designed a Dell, an Indian designed HCL, understanding one another. How is that possible? It is possible because the internet worked, the whole internet. When I say internet, it includes laptops, routers, switches, firewalls, everything which communicates over the internet is an internet. Everything that communicates. All are speaking one common language. That is why, they all talk. They all talk each other because they all have one common language. What is that language? OSI. Open System Interconnect. It's a standard which should be followed by every vendor. Whoever designs a device for internet work, they all follow one common standard. Because they all follow one common standard, they all can communicate each other. As I said, a laptop manufactured in USA and laptop manufactured in India, they talk each other. It is because both have been built by referring this particular standard. One common standard every device will follow. Not only laptops and computers, even the routers. This is how we draw routers. What is a router? A device that helps to communicate between different network. A device that helps to communicate between different network. We'll talk about the routers in detail later. But as of now, what I'm trying to say is a router or a switch. This is how we draw a switch, a rectangle box. A router, a switch, you know, computers, firewalls. This is how we draw firewalls. All this, even your cell phone, your mobile, all these are manufactured by referring one common standard. So you may have a Samsung phone or an Apple phone. You may be talking to me. I'm having a different company, but still, when you speak, I can hear your voice in my phone. When I speak, you can hear your my voice in your phone without any change. Same meaning has been conveyed. And when I take my phone and message you, your cell phone understands the same meaning of what I am sending. When you typed "I'm in, sir," I got "I'm in, sir." I did not get any other word. When I say, "Please give me your email address," you understood that very correctly. It is because my cell phone has communicated your cell phone exactly the same thing. Your cell phone also understood what I have sent. So, regardless of vendor, regardless of manufacturer, our data is being sent and received without any change in the meaning. It is all because they're all manufactured using one common standard. We have one common standard, and that standard is Open System Interconnect, OSI. Have you heard this thing in the college anytime before? OSI? Correct. OSI, correct. Very good. So you already know networking. I appreciate. OSI is a model. The other word for model is a standard. OSI is a standard that every manufacturer follows so that they can also be part of network. See, I can also design a computer without referring this model. But the problem is my computer when it speaks, others won't understand the same meaning. But when I design a computer following a same model which you have designed, then my computer and your computer can understand each other. That's why we need OSI. We need this OSI so that all vendors, all manufacturers will refer to this one common standard when they manufacture. So without conflict, without misunderstanding, the meaning can be conveyed. So far, what I have said is the purpose of OSI. The purpose of OSI is to provide a common language, common standard, all right? So this common standard has got 7 layers, and the 7 layers are logical layers. The 7 layers are logical layers, they are not physical. Why do we need to learn the 7 layers? This is explaining us how a data is prepared so that it can be easily taken from one place to another, which can be easily interpreted on the receiving side without any change in the meaning. See, when I speak, you understand. How is that possible? I'm just talking to the mic here in the laptop. The mic is taking my voice. I'm not directly talking to you. I'm not close to your ears. But still, the speaker this mic takes my data and prepares my data so that the data is well understood by the internet first. And then the internet translates back into the human language when it reaches your computer. So from my language, from human language to the internet language, someone is preparing the packet so that internet will understand exact meaning of what I'm speaking. So that internet can carry my voice to your home, and in your home, the internet language is being translated into the human language without any meaning changes without any changes in the meaning, and it comes to your ears. See, if you don't have the 7 layers, this is not possible. Exactly what I'm sending here, you are receiving there. But in the middle, it's not a human being in between you and me. It is the missions. The missions, the routers, switches. First, they need to understand what I'm saying so that they can carry it without any change to your end, and from your end to your laptop, it gets translated, and in the speaker you hear my voice. That 7 levels of preparation, that 7 levels of preparation to our data is what explained in OSI. So if this preparation is not done to our data cannot reach you. That preparation, the 7 levels of preparation is what makes my voice to be eligible voice to be there in the internet. That preparation is very important. The 7 levels of preparing my data is what explained in this OSI 7 layers. So if someone is asking, or uh, if you want to say someone what is OSI, what you will say? OSI is a reference model. OSI is a standard which has been referred by every vendor while they design their network device. The network device can be a computer, can be a mobile phone, can be a server, can be a printer that need to be in the network, can be a router, can be a switch, can be a firewall. And this 7 layers of OSI also explains the functions, the preparations that is being carried out so that my data can be eligible data in the internet. The preparation. Now the 7 layer is as follows. Layer 1 is physical layer. I go from down, that is how the standard goes. Layer 1. Layer 2 is data link layer. See, it's a standard. You should exactly follow what the standard says. The standard says the first layer is physical layer, and the second layer is data link layer, and then the third layer is network layer, and then the fourth is transport layer, and then the fifth is session layer, and then the sixth is presentation layer, and then the seventh layer, the final layer, is application layer. Right? So these 7 layers is what the 7 levels of preparation done to your data so that the data can be easily understood by the network, carried from my place to your place, and again translated back to your understandable language. See, over the internet, over the wires, it is not in the English language it goes. It goes in bits and bytes. In the wire, it is only bits and bytes that is going. It is not my voice going, but my voice is being translated to the bits and bytes. And it comes to you in the form of bits and bytes. You means your computer. And your computer translates from that bits and bytes to my voice. That is how you are hearing me now. You see, this 7 layer of preparation, if one is missing, the packet won't even leave my laptop. All the 7 layer needs to work for our communication to happen. If one layer don't do its work, for example, data link layer is not providing the MAC address. MAC address, you might have heard about MAC address, you might have heard about IP address. If the data link layer don't provide a MAC address, then the packet is not eligible to send out. My PC cannot send the packet out. All 7 layers have to do their job. Again, as I said earlier, this is logical layers. These layers are not physical. This explains the functions, the preparations. For us to understand how it has been prepared, how first comes the application layer on the top. Though it is called as layer 7, if a computer is sending data, if A is sending data to B, it starts from here. It starts from the application layer. You see, I open an application to write an email to you. What is it? It's an application layer. So it starts from here and then it goes in the wire, in bits and bytes. And on your side, it is going to be the opposite. It's going to be the opposite. You receive in the physical layer, and then you can see the data in the application layer. Here it is created in the application layer and sent from the application layer. Here it is received in the application layer. You are able to see my data. Say right now I'm talking to you. It is the application layer which is catching my voice. The Google Meet, which is listening to the mic. From that application, it goes down here, and then the physical layer puts it into the wire, and it goes in zeros and ones until it reaches your home router. In your home router, it routes the packet to your laptop or computer, whichever you are using to attend this class. In that device where you are sitting now, with which you are sitting now, it is received in the physical layer. And then one by one, each layer does its duty and you are able to hear my voice. You see how quickly it happens. As I'm talking, you are hearing there. But all the 7 layers are doing their job very fast in a microsecond speed. Not only that, the network in between my home and your home, see how fast it is. As I am talking, you are listening. You can understand what I speak. There is no delay. Spontaneous, fast, very fast. No delay at all. There is a delay, but human ears cannot find the delay. You cannot find the delay that is happening. When you speak, I cannot find the delay. So fast, but definitely there is some time taken for your voice to reach me and my voice to reach you. But it is less than 300 millisecond. That is why I can understand you very well. You can understand me very well because it is very small delay, which is okay for a human ears. If the delay is more than 300 millisecond, then you will easily understand there is a voice breaking. You will tell, sir, voice is breaking. But you don't experience a voice break here. The reason is the delay that is between my laptop and your laptop is less than 300 millisecond. So fast. You see how big is network? Very fast. Very fast. All the 7 layer in my laptop is working, and the network in between you and me is taking the data very fast to you, and your PC from physical to application layer it decapsulates, decodes, and you are able to hear the voice. See how big it is, the internet, and how fast it is. It's very big and very fast and very smart. Right. So we are going to deal with this standard in our next class. We are going to go through each uh, layers one by one. But before that, we have to also understand some devices that is there in the internet. We'll come back to OSI layer again in our next class. So we will now move on to another topic called devices, another fundamental topic called devices. You see, in the beginning, there was a device called amplifier. Why do you need an amplifier? To amplify the signal. You see, the wire that we have has got a limitation. If A and B is too far away, then there is a need for an amplifier to amplify the signal. The signal is sent from here, but as it is traveling, it is becoming weaker. Amplifier again strengthens the signal so that it can reach the other end. But the problem with the amplifier is on on the way to my destination, this is my destination. This is the source. On the way to destination, this red color is noise. What is noise here? Some electromagnetic field, it is creating this data. It is not the data that I send. It is just created on the way by electromagnetic force, like earth gravity force. Yeah. So that noise is also amplified. So the destination guy, when he receives the data, he's not only receiving the data, he's also receiving some unwanted symbols and letters. Say for example, A is sending I'm fine. But when the receiver receives the data, it is not just I am fine, it is having some at symbol and then I and then space and then A and then a dollar and then M and then space and then equal to and then F and then I and then 1 and then N and then some hash symbol. See, it has confused the data and then E. The receiver cannot understand this. It is all because of this noise that got added in the middle. So they came up with another device called a repeater. What repeater will do, it will filter the noise and it will regenerate only the data, only the actual signal. So now the destination is not receiving noise. A repeater, P-E-A-T-O. This repeater regenerates only the signal, regenerates. Generates only the data, only the actual signal, not the noise. Repeater is good, but the repeater is not big enough. Why? This repeater has got only two ports. So I can only connect two devices and communicate. If you take a house today, in a house itself, you have at least three laptops, four computers at least. In a normal family, in a big family with three children, I have two, three computers at home now. So a repeater is not enough. So they came up with another device called hub. Hub is a multi-port repeater. Multi-port repeater. Hub is a multi-port repeater. This hub has got many ports. It's a multi-port repeater. Same job what the repeater does, hub also does. This also regenerates only the data. Hub also regenerates only data. But the good news is you can have more devices connected to it, not just two devices. Because it has got more ports, you can have more devices. So hub is a multi-port repeater, good than repeater because this has got possibility of connecting more devices. But again, there is a limitation for the hub. The maximum port is only 8 ports. That's the maximum ports a hub will have. The reason is hub has got only one collision domain, and one broadcast domain. We'll talk about the collision domain, broadcast domain in our next class. I do not want to get into that now, but there is a reason for why it is 8 port. And this is the reason, but the meaning of this I'll explain you in the next class. We'll move on to the next device, which is called bridge. Bridge is a software-based device. Software. So bridge is better than hub. Bridge will have more collision domain. In hub, we saw only one collision domain. Bridges will have more collision domain. Bridges have got more collision domain. Because bridges have got more collision domain, How many more? Let's say you have a 24 port bridge. Then you will have 24 collision domain. Whereas hub has got only one collision domain. Whatever, we'll talk about the collision domain again. I'm telling you, we'll talk about this later. I'm just giving you a reason why bridges are better than hub. Bridges are having more collision domain, collision controller. To control the collision, there is more controllers here. Now, again, the bridge is a software-based device. That's the drawback. So there came another device called switch. Switch is the hardware-based device. Hardware-based device. Switch is more popular than bridge. Now, switches are called as LAN device. Switches are called as layer 2 device. In OSI, data link layer is what we call it as layer 2. Switches are data link layer device. And these 2 points are common for this one, bridge. Yeah, these 2 points. Bridge is also a LAN device. Bridge is also a LAN device. Bridge is also a layer 2 device, like a switch. Yeah. So at last comes, another device, router. Router is a WAN device. Router is a layer 3 device. What is layer 3 in OSI? Exactly. Network layer. It works a network layer. Yeah. So we will be discussing on these things in more detail in the next class. We'll start from this device once again. We'll learn what is this. Yeah, after this we'll get into OSI. We'll finish this one in the next class as the first topic, collision domain, broadcast domain, all the stuff, and then we'll get into OSI layer and do a detailed study of all the 7 layers. Okay, so the reason why I took OSI layer first is I want you to know that there's something called data link layer where these devices work. If I teach this one first and say layer 2, and if you don't know what is layer 2, then problem. So I just took one small quick walkthrough in OSI to teach you these things. We'll finish the device topic as a first topic tomorrow, and then we'll get into OSI. Is that okay? All right then.